Hey everyone, I'm Joel. I'm going to show you how to deploy a 3-node object storage platform on your Mac laptop using KVP Base. Before we get started, just make sure you have Mono installed. If you want to download and install that, you can go to mono-project.com/download and you'll find it. Once you have that installed, the first thing that you'll want to do is download the binaries from kvpbase.com. So you can see on the website here, you can see the big green download button for the storage server and also the big green download button for the load balancer. I've already downloaded those binaries. You can see this directory that I'm in here, the two binary files right here. I've already unpacked those into the 4 directories beneath it, LB for load balancer, node 1, node 2, node 3. So the first thing that we're going to do is go through the initial setup wizard on each of these. We're going to first run the Mono ahead of time compiler, and then we're going to run the setup script on each of the nodes. So we'll run the Mono AOT. Just did that on node 1, node 2, we'll do that on node 3 now. And we'll do that on the load balancer also. Okay, so now we're going to go through the initial setup wizard on each of these nodes. So we'll do node 1. And node 1, we're going to set this up to listen on port 8001. If you're setting up your system to run multiple nodes on a single machine like we're doing, you can do that. It works great. You just want to make sure that each node is listening on a different port for obvious reasons. So we just set it to 8001 right there. That created everything that we needed. If we wanted to, we can grab any one of these URLs here. So let's just grab this first one just to make sure that our node is up and running. And right there, you can see that the node is up. So we'll go back here and we'll do the setup wizard on node 2. And with node 2, we're going to set this one up to listen on 8002. And again, if we want to verify that the node is up and running, we can do this. I'll just do it one more time. I won't bother with node 3. I think you get the point. You can see the nodes running. So getting a single node up is really easy, and I think what you'll find is that doing it with multiple nodes is every bit as easy. So now we'll go to node 3. We'll run the setup wizard, and this one will listen on port 8003. And that takes care of that. Now the next thing is to set up the topology. There's a file in each one of these nodes called topology.config. You can see that right there. It's a simple JSON file. We're going to open this up and we're going to edit it so that each node knows about every other node and it is aware of to whom it is replicating data and who its replication partner is. So we'll just open this up here. And the only thing that we need to do is expand the nodes array. We have 3 nodes, so we'll add that here. And just set the node IDs accordingly. We'll set the ports. And then what we're going to do is set the neighbors. The neighbors is just an integer array, and it specifies who each node considers a replication partner. So in this case, I'm going to have node 1 replicating to 2, node 2 is going to replicate to 3, and then node 3 is going to replicate back to 1. Okay, and each node will know what their setup is based on the ID to which they point, based on this first value that you see here. So if we copy this and we take this to node 1, when we start node 1, it's going to look for the entry in ID 1, and it's going to start listening on port 8001. So we are in the node 1 directory. So actually, we'll just delete the file. And we'll do the same for node 2. But on node 2, we're going to change the current node ID to 2. And we'll do the same on node 3. Okay, so now each of these nodes is aware of one another. So all we have to do is start each of them, and then we can check and make sure that they can all see one another. So I'm just going to open 2 more terminal windows here, and just go into the correct directory. Go to node 2 here, go to node 3 there. And if at any point you get lost, any command you would ever need is right there in the README file. So just to make it simple, I'm going to go back here. It's going to give me a warning about license keys. Just ignore that for now. Okay, so each of the nodes have been started. So what we want to do is see if we can see any of the neighbors on the system. So I'm just going to list the topology. There we go. And so you can see on node 1, we can see 2 different neighbors here. We can see node 2 and node 3. Both are okay. You can see that node 2 is considered a neighbor by node 1. Node 3 is not considered a neighbor. The neighbor flag is not there. The host name and then the host name port tuple are listed there. You can see when they were last spotted. And similarly, if I go here, you can see node 2 considers node 3 a neighbor. Node 1 is not a neighbor, but it sees it as part of the topology. And again, here, node 3, it sees itself as node 3. Node 1 is a neighbor for replication and such, and node 2 is just part of the topology. So let's just make sure that everything is up and running here. We'll go back to our REST client, and we'll just make sure that we can view some of the content that's on one of these nodes. So we'll just use the default API key, and I messed something up. Give me one moment. Oh. Pardon me on that. I had a remnant from a previous operation. There we go. So you can see that we were able to retrieve that HTML file there. And if we were to put this in the browser, we could... Oh, and notice also that we did that against node 1. We can actually do that against any node in the network. It doesn't have to be node 1. It could be any one of them. So if I go back here and I change this to node 2, we'll be able to get it. If we go to node 3, we'll be able to get it. So we can actually go to any node in the network and get access to the data. So the nodes will internally figure out how the request needs to be routed, and also to route around failures. So if one of the nodes were to fail, it would be able to resolve that matter on your behalf, and you could still go into any active node. So what you can also do is put a load balancer in front of all of these nodes listening on a different port, and you can run your requests through the load balancer. So the load balancer will establish connections to the backend storage servers, and as requests come in on the load balancer port, it will then distribute those requests to the backend nodes based on the load distribution algorithm and availability and such. So let's go ahead and set that up. I'm just going to open a new terminal window here. we're going to go into the load balancer directory, and we're going to run setup on this. Let me first go into super user because we're listening on a TCP port, so we need to run as super user or as root. And we'll just run using the command here in the README file. And as you're doing this, if you get license errors, just ignore them. They won't affect the operation of the system. So we're going to skip that. We're going to listen on localhost. We're going to listen on port 8000. So remember, nodes 1 through 3 are listening on 8001 through 8003. The DNS name, now we're actually defining the nodes that the load balancer will be sitting in front of. So the DNS name for these, we can really set it to whatever we want to. We're going to have a loopback URL, so let's just go ahead and keep these as localhost. The HTTP port on this is 8001. We're not going to be using SSL for now, but you certainly can. And we're going to be connecting for the heartbeat on HTTP localhost 8001/loopback. And the load balancer will check this URL periodically to make sure that it's alive and so on. And if it is, then it considers the node to still be online. This is actually a URL that the KVP-based storage server software has to respond to itself. So that obviously means that the software is up and running. Okay, so now we'll add node 2, which is running on port 8002. And node 3. And we'll press enter when we're done. And the setup wizard will take care of all of the configuration files that that we need for system operation. And again, ignore the license warning there. So now if we do a list endpoints, we can see that we have not yet had any failures on these nodes. It's already connected to each of the nodes, which is a good thing. We can see that each of the nodes is okay. We can see what the response in milliseconds must be, that what the timeout is. We can see how long the last responses took, when they were attempted, and when they last succeeded. So this is a very helpful command for determining which endpoints you have. So we're going to go back to here and change this to our load balancer, and our load balancer is going to take the request and it's going to distribute it as it needs it. You can see it routed me to node 3. So anytime that we send a request to the load balancer, it's going to figure out which node is active and online, and it's going to route that request on our behalf to that node. So if a node goes off, it will pull it out of the rotation and will get routed to a different node. So thanks so much for checking out our video. That was hopefully informative. A very quick way to set up a multi-node local object storage platform on your own machine. I did it on my own Mac. You can do it on yours. You can do it on your own servers, however you see fit. Thanks and have a great day. And visit us at www.kvpbase.com.